Wednesday. I'm gonna be gone. I have to be out of town on Wednesday, and so you guys will have a sub. I'll get the lab Wednesday. You can we'll go through some stuff today. I don't know if we have time. I want to start introducing something new today. I hope we get a chance. I don't know if we will. We'll see. It's a short period. Tomorrow, I'll tell you what, let me think about that. I might even make that due date Thursday. We'll see. Possibly. Just because I'm going to be gone, I'll think about it. But it's for sure no later than Wednesday. Okay, so on this stuff now, what I'd like you to just, I know you obviously you can't look at your assignment right now, but you can probably remember. So, yeah, I know. I wish we had them. Nobody has them. I mean, we have some that we can borrow. I should have gotten them today, I suppose. Can you? No, we won't. We won't. I mean, that's tempting. No, we don't have enough time today. Okay. How do I? Okay, so here we go. Can everybody see that? Okay, I mean, it's not great, but a little bit, sort of, kind of, maybe. So, issues.
Like 12, 13, and 14.
12, those are the ones those are kind of the heavy hitters. Okay.
That's a lot of work.
What do I have to do? Yes, okay, good. What? I don't understand what's going on here. What is this doing? I don't know what's happening here. No. No. That's what I get rid of.
37.
There we go. Okay. There we go. Okay, this guy. Here we go. Okay, this is getting a little fun now. When we're too much talking. I know that was I got interrupted there and I had to fix some things, but you got to be ready to spring into action here. So something like this. All right, so it's been a while. Let's review. When we are trying to evaluate limits analytically, so we're not using any hokey graphing or tables now. We're trying to get the answer algebraically. Quick review. What are our three kinds of outcomes when we take limits? We take a limit either.
There could be no limit.
Okay, there could. Now, what's the easiest case?
Direct substitution.
Okay, direct substitution works, right? We're going to try direct substitution, and it works. We said this was like a type 1 answer, right? We get an answer that does not have a 0 on the bottom, right? Could have a 0 on the top, but it's going to be some rational answer that is a number, and that's it. That's the limit. That's the value that the ant is approaching as x approaches c, and we're done, right? Those are easy. Direct evaluation works. Okay, the other kinds. What was the second kind we talked about? Indeterminate, and that's what we get when the fraction, when we try direct evaluation, the result is 0 over 0. That means more work, right? We've got to do something analytically, algebraically, right? Those are the kinds, for now, that you're going to be working on primarily, because those are the ones that take a little practice. Hunter, what's the third kind?
Look at my notes.
Yeah, okay, yeah, come on now. No limit, and those are the kind, the hallmark of those. We know it's that case when we try direct evaluation, and what happens? 0 on the bottom, but no 0 on the top. Good. Okay, those are no limit for now. We're going to talk more about that. I don't know if we'll get to it today, but we're going to get to that shortly. We're going to be able to say more about those in the future. Okay, there's our brief review. So if we try to evaluate this limit directly, what happens? 0 over 0. All the x's go away, and I just get 1/6 minus 1/6, which is 0 over 0. So it's the dreaded no, or more work kind, right? Okay, so what does more work amount to here with these? Now, I gave you kind of a hint in the lab, but I don't think we even actually did one of these. It's all right, you can do them. But what do you suppose we're going to do with this? Okay, this is, right now, this is not, there's another kind of these that we saw, which is actually harder. The kind where you have radicals and you got to rationalize, you got to use the rationalizing approach where you're going to multiply by the conjugate of the expression with the root in it, right? Those are a little tricky. This kind here, these are sort of, I would say in a way they're almost the easiest ones, because you don't really have to, I don't know if they're the easiest. Maybe the factoring ones are fairly easy too. I definitely think the radical ones are the hardest kind. But these aren't too bad, because really all you need to do here is you need to just simplify this, and in the process of simplifying this ratio of fractions, you're going to be able to cancel the offending factors, the ones that cause the 0 over 0 behavior, right? So let's go through this one. So if we've got something like this now, I'm going to start over. So the limit of 1 over x plus 6 minus 1/6 over x as x approaches 0. We already know it's indeterminate. How are we going to simplify this? What's our algebraic rule? What do you think, right?
Can you times top and bottom by 1 over x?
We can, and I think what you're getting at here is on the bottom we have an x over 1, and you're right. We're going to do that, because if we've got a ratio of fractions, our strategy is always to simplify the top into a fraction, right? Simplify the bottom into a fraction, and then flip and multiply by the bottom, right? Bottom's done, but the top is not. What have we got to do on the top first? What do you think? Yes.
Could you just get like the same denominator?
Yeah, good. When we want to add or subtract fractions, the way we simplify that is just by getting a common denominator and combining terms, right? So what do we do to the first fraction? If we want to, what is our common denominator going to be?
X plus 6.
X plus 6.
Good. Okay, so 6 times, we would probably say that it's 6 times the quantity x plus 6. Right? Quantity means it's one thing. It's in parentheses. So on this one, we're going to multiply by 1 in the form of what over what? 6 over 6. Good. This guy over here is going to get multiplied by x plus 6 over x plus 6. Okay, and if we do that, then the top is the nasty part here. I've got to keep my limit notation because I have not taken my limit yet, right? We're still in the process of just massaging the arguments of the limit. Meaning we're going to take everything in the limit and do some algebra on it to make it look better. What do we get from this fraction? 6 over 6 times x plus 6. Now there's a temptation probably to want to distribute. because you're overachievers. You feel like you gotta be doing everything, you're never doing enough. There's gotta be more to do, right? Resist that temptation, and you'll see why. This is gonna be sort of a self-cleaning process. When we take the limit and the x's go to 0, there's really no reason to do all that algebra, and you'll see why in a second. So there's our common denominator, right? What we got from the first numerator, we got 6. What are we gonna get for the second one?
-6.
Minus
Oh, minus.
the quantity,
You're open x plus 6.
right? Everybody agree?
Yeah.
Okay. All divided by
X over
x over 1. Now I'm gonna do that just so we can make sure we keep the top and the bottom straight. Okay, if I distribute, let's further simplify this. If I distribute the negative sign on the top, what happens?
Negative x plus
6 minus x.
Oh, okay, this is gonna become a negative x minus 6, right? And so the 6's are going to cancel by addition. And now I want to make sure we get this terminology and vocabulary straight here. When we talk about cancellation, we really talk about cancellation in 2 ways. We got to make sure we're keeping these straight. When we cancel things vertically, they're canceling to what?
1.
To 1, right? A vertical cancellation cancels to 1. So 1 over 1. A horizontal cancellation, when we're adding opposites, cancels to 0. So it really can't. It goes away completely, right? So the 6's go away completely. So then we end up with the limit of, on the top, we just get a negative x, right? Okay, that's good. So the top is much simpler now. It's just a negative x over 6 times the quantity x plus 6, all divided by x over 1, right? Okay, do you think that's enough? If we try to plug in x equals 0, evaluate this thing, is it going to be fixed yet? No, it's not, and it shouldn't be, right? We haven't canceled anything yet, right? We have to cancel those factors before that's going to happen. But now we're to the point where we can take Ryan's suggestion and we can just flip and multiply, right? So this now looks like the limit of negative x over 6 times the quantity x plus 6 times 1 over x. So now, what happens? Important. Yes. These guys cancel. And I just end up with, on the top, a negative 1, right? So the whole top is just negative 1. The bottom is this stuff. Now do you think I can take my limit? I can, right? I can. Now we've canceled those factors, and when I take the limit, do you now see why it was really, not only was it not important to do, it probably was even confusing to distribute that 6 on the top, because now when x goes to 0, what happens to that quantity? It's just a 6, right? So I just end up with 6 times 6. There's no reason to have distributed that because the x's were going to go to 0 anyway and just disappear. Make sense? So then when we take our limit, our final answer is just negative 1 over 36. Okay? So we did a lot of stuff. Let's kind of distill that down to what big picture, what did we do? We had a situation where we were trying to evaluate a limit involving complex fractions, right? Fractions inside fractions, fractions on the top, lots of fractions, that was indeterminate. So our strategy in that case is to simplify all the fractions on the top, simplify all the fractions on the bottom, flip and multiply, which allows us to cancel something important. And then that's it. Then we can just evaluate the limit. Okay?
Sweet.
Make sense? Okay. Okay, so, oops, I don't want to go there yet. Okay, what else? Let's go back to, and you really, we need to spend, I know that, well, let's make sure we get all this stuff taken care of first, and then we'll look at some trade things. Okay, this one. This guy, is this a nasty one?
Yes.
Looks scary. It's got all kinds of weird deltas in it. And oh my goodness. What's going on here? Okay, so what about this guy? Now, there's something important that you have to, and really don't panic when you see deltas and x's and all. It's just pause for a second and allow your mind to sort of absorb this and wrap your brain around it and see what's going on. How many different kinds of variables are represented in this limit? Two. There are two. What are they? X and delta x. Okay, here's an important concept that we will come back to. Which is, now don't say anything out loud for a second. Everybody think about this. Which of those is the variable of the limit? Delta x, right? How come? Because delta x is the thing, it's the entity that is approaching a value in our limit, right? The x is not approaching anything. Is x generally a constant or a variable? It's a variable, sure. But insofar as the limit is concerned, is that x a constant or a variable of the limit? It's a constant. It's not changing during the course of the limit, right? Does that make sense? The only thing that's changing during the limit is this value of delta x is approaching 0. That's not a huge deal right now, but I just kind of want you to begin to think about that. All right, so in this case then, if I try to evaluate this limit as delta x goes to 0, everybody see that I'm getting 0 over 0 again, right?
Yeah.
Okay, so what do we do this time? What do you think?
More work.
More work. More work, exactly. What's that more work going to look like? And here's another one. I don't think we did any like this, but that's okay. I mean, you're going to see some that we're not going to do them all in class. What do you suggest?
Expand.
Okay, expand. Let's expand. This is, now factoring, does everybody agree that factoring is not really going to work here? The only thing we could factor out on the top, when it's written like this, is a 6.
Yeah.
Everybody agree? That's not helping us, right?
I just wanted to say the wrong answer first.
So factoring is our ultimate goal, but we can't factor this one directly like we could have, for example. Let's just compare this real briefly to if we had the limit of, say, x squared minus x minus 2 over x minus 2, right? 2.
Yeah.
As x approaches 2. Yeah, that's right. That would go to 0, right?
Yeah.
0 over 0. But that's one we could just factor directly and cancel the factors. That'd be an easy one for us now, right? Okay, this is not like that. This is one where factoring doesn't work, so really our only option here probably is just to expand this bugger out and see if we can get some fortuitous canceling of terms that are going to help us, right? So let's try that. So if we expand out x plus delta x quantity squared, what does that look like? Plus
2x delta x
good plus
delta x.
good.
No, okay, how did you get that?
Okay, how do we get that?
You expand. Oh.
Okay, you can FOIL it out for now. I am going to show you I don't want to break our momentum here, but I'm going to remind you about how to do expansions using the binomial theorem soon, but not today. But I mean, you can always just FOIL it out. Okay, minus 6x squared over delta x as delta x approaches 0. Okay, so let's do a couple things at once here. If I distribute the 6, first of all, do you see any cancellation? Aha, you do. If we distribute the 6, would you agree that that term and that term go away?
Yes.
Okay, so we're left with then. We're left with oops, limit. I can't forget. I hear I always tell you not to forget to write limit. I just about did. Limit of, what are we going to get? What's left? Okay, is that enough?
You can factor.
Okay, now we can factor. We haven't done enough yet because we haven't canceled anything top and bottom, right? But now we've eliminated enough terms that this does factor conveniently for us. What can I factor out?
6 delta.
Okay, I could take out a 6 delta x. That's fine. I'm just gonna take out a delta x.
But
They'd both work.
aren't those different terms then, because it's 12x?
They are. You're right. You're right. But let's see if that makes a difference. So I factor out a delta x, leaving me with
12.
6.
plus 6. Delta x, whoops. Okay, did I write? Yeah, I wrote no problem. Okay, divided by delta x. There's our cancellation, right? Does that make sense that that's the important cancellation because that's what's causing the 0 over 0 behavior, right? So those go away. Question?
If we would have taken the 6 out, then.
It wouldn't have mattered. Then we just would have had a 6 out front and we would have been left with a plain 6 instead of a 6 delta x. Same thing. And so then if we evaluate our limit, if we let delta x go to 0, what happens to this term? 6 times 0 becomes 0. And so our answer is just 12x. It's a weird answer, and maybe it's possible people even got the answer and just thought, well, there's an x in it, that's weird. But that's okay, because the x was not being affected by the limit, was it?
No. Oh, okay, I get that.
Okay?
Got it.
All right. Now, as bizarre as that one looks, and doesn't that look, that's a pretty weird one to throw at you, right? There's a real reason you got that one. We're going to see a lot of them like this coming up in the next month. You'll do lots of them like that. Okay.
This one's in there.
All right. All right, so 14? Okay. So would everybody agree? Now this one looks terrible, right? Let me just blow this up. We won't do it.
Oh, yeah. Yeah, you see the previous.
Okay, real quick. If we try to evaluate this, you've all tried and it's 0 over 0. Okay, what are we going to do here? Yeah, exactly. We're just going to expand out and distribute, right? Okay? And what do you think is probably going to happen? What do you anticipate is going to happen? Yeah, stuff's going to cancel out. Just the right stuff is going to cancel out on top so we can factor out probably what? A delta x. Same kind of thing, right? Okay?
Okay, we're not gonna go over this one.
No, I'm not going to go over that one.
Sorry.
Not right.
I knew it was the same.
Aha, okay.
Yeah.
This guy, all right. Okay, once again, I get 0 over 0. Okay, this was the weird one. To me, this is the most counterintuitive one. If you don't know the strategy, this would be sort of a hard one to just intuit. What is our strategy, though, when we get something like this? Yes, good. We're going to rationalize, which means, well, you could. You could split the denominator. Now, that's a tricky way to think about this. Does everybody see that?
Yeah.
We could, and this is pretty tricky, we could think of the bottom as being a difference of squares if the squares are the square root of x and 7. Very tricky. But the way, and that works. The way we talked about this, though, whenever we have an irrational expression that is causing some indeterminacy, like right up here, this is causing the top 0, we want to rationalize the numerator in this case, right? We want to multiply through by the conjugate of that expression. And this is, in the book, they would call this a rationalizing strategy or something like that. I don't know. But that's the whole point is we're going to rationalize the numerator. We're going to get rid of that square root. Okay, so let's walk through this one. It's good, probably good to practice this after a week. So what's that mean? Top and bottom get multiplied by. Good. Okay, so what does that give us then on the top?
49 plus minus.
49 minus x, agreed?
Yeah.
Okay? Because I'm gonna get, and our pattern here is a minus b times a plus b is a squared minus b squared, right?
Yes.
Okay? Everybody got that?
Yeah.
Okay.
Oh, and then.
Now the bottom looks kind of ugly,
I just keep it out.
okay, but it's okay. It's just gonna stay ugly. So on the bottom, we've got x minus 49 times, that quantity x minus 49 times the quantity 7 plus the square root of x. Okay, we don't quite get the cancellation we want there though. What do we need to do?
Just JW.
Yeah, but you're right, I'm gonna keep going, but in order for us to eliminate the indeterminacy, we've gotta be able to cancel something. And something wants to cancel there. What can I do?
Times it by negative.
Okay, but now we gotta be careful how we say this. I can't just multiply something. I've either gotta, remember, all I can do in algebra and retain the identity of the expression I've got is I can either add 0 or multiply by 1, right?
Well, let's
Okay.
multiply by
Let's multiply by 1.
one.
So,
So we get the top and bottom.
right, so if I were to multiply both the top and the bottom by -1, what's gonna happen? Another way of thinking about that, okay, that's fine, but I think that's gonna be a little more confusing. That'll work, but to me, a better way to do this would be to factor out what on the top?
Maybe negative.
A -1. Okay, I'll show you in a second how they're the very same thing, but would you agree that the top, I could replace the top with -1 times the quantity x minus 49?
Yeah. So then it'd be like
Agreed?
plus. Because, okay.
Does that make sense?
Yeah.
Okay. And so now this, I've got this factor x minus 49 that cancels, right? But I've got a -1 on the top then still, right? Okay, so the whole top just becomes -1.
So did you just multiply the top by -1?
I didn't multiply by -1, I factored out a -1,
Factored out. Okay,
right?
gotcha.
Okay.
Yeah. Okay.
Alternately, the other way I could have done that is this. I could have gone, could have also done this, right? I could have said, okay, I could multiply the top and the bottom by -1. If I distribute a -1 through the top, isn't that just going to become x minus 49? -49 plus x, right? The bottom, I would have a minus sign. And now those would cancel. And I still I got the minus on the bottom this time, but big deal, same thing, right?
Okay.
Okay, makes sense? Either way, okay? I'm gonna do it the other way though, if you don't mind. I just think that's a better way. Okay, so now I can evaluate my limit, right? I can take my limit, we'd say.
Yeah,
And
put
it's
that
just
49 in.
14.
Yeah.
Negative 1 over 14.
X, or 7 plus the square root of 49 is just 7 plus 7. There it is.
Negative
Okay, make sense?
Yeah.
All right. How much time do we even have?
We have 3 minutes.
3 minutes is it?
Yeah.
Mondays are so, I know, and we are having so much fun.
I know.
Okay, I think, so everybody's okay with that stuff now?
Yeah.
Okay, I don't have time to do the trick stuff today. We'll just do it
That's
tomorrow.
all right.
I don't mind.
I've got to take roll. I haven't taken roll yet.